Welcome back. So let's go ahead and continue our discussion of quadratic surfaces, graphing them. So when we look at a question like number 5, so let's see if we can go back and review what shape this is right here. Notice one of our terms is just by itself, x equals, single variable, no power to it. The other two have a power. So it's got my elliptical cone. No, they're all squared. Up there it is, my elliptical paraboloid. Notice, so this is my elliptical paraboloid right here. So let's see here. So the first thing I'm going to do is I'm going to write down the shape of it. This is an elliptical paraboloid. So when I'm graphing an elliptical paraboloid, I want to find out the main axes. So that's why I look here. Remember, I always look for the odd one out. So these are both square. This has no square to it. So this is the odd one out. So what that tells me, because it opens, it's the odd one out, this tells me that this is going to open on the x-axis right here. To get the center, let y and z both equal 0. If I do that, my center is going to be just 0, 0, 0. So I'm going to have a point at 0, 0, 0 right here. Now, when I graph this, I'm going to graph an elliptical paraboloid coming out. So to kind of give an idea of what this looks like, we're going to look at what we call the traces. Remember, the traces are like little intersections. For example, if I look at, let's say, x equals, or the xy plane, or sorry, if I let x be 1, if I let x be 1, coming out this way, we're going to get the equation 1 equals y squared plus z squared over 4. And if you notice, right here, this is an ellipse. That's my trace. Matter of fact, if I let x be any number, I'm always going to get an ellipse. So that means as I'm extending out from the origin here, and I'm heading out towards the x-axis, I am getting these larger and larger ellipses. Now notice z is always bigger than the y, so it's kind of stretched out this way. For example, when x is 1, z is 1, so it's going to be kind of like this. And it's going to keep getting larger and larger and larger. So to graph it, we just do our best to kind of match that. Now this looks terrible because I just try to graph like that. I told you I'm not very good at this stuff, but we don't have to be the best. So I'll just show you a quick way to graph it. We just want to make sure that we kind of make a paraboloid like right here. So it's going to come out like this. This is kind of how I graph it really in reality. Graph it like this, like so. And that would be our elliptical paraboloid. So there's the ellipse right there. Now where do we get the paraboloid from? Now there's, just to show you that where we get the paraboloid from, let's let y be 0. Let's let y be 0. If I let y be 0, let's take a look here. I'm going to get x equals z squared over 4. And there's our parabola. Parabola. There we go. So what that's telling me is anything of, so on the z plane, we're going to have a parabola. And that's really what I draw. I'll start with my parabola right there and we go around. Anyways, they're not going to be, you're not going to draw these really pretty. Mine looks terrible there, but you'll get the idea. These aren't too bad to do. Alright, the next one is similar to this one, except they're all being squared and it's equal to 0. This is my elliptical cone. Elliptical cone. So which one's going to be my main axis? I look for the odd one out. So this is my odd one out. Therefore, this will open on the x-axis right there. So I need to get my center, just like we did here. That's easy enough to do. It's just like drawing a circle, right? So it's going to be 0, -1, 0. So I'm going to go to 0, -1 on the y, and 0 on the x. So there's my center right there. If I look at the traces, so let's just talk about the traces. Again, remember, this is just to help us out. If I look at like the YZ plane, in other words, let x be 0, notice what I get. Y plus 1 squared plus z squared equals 0. So if I try solving it, I would get y plus 1 squared equals -z squared. And that's nothing. But take a look. That's going to be nothing. So you can't have that. That's a D and E because you can't take the square root of a negative. But what if we want to take a look at, let's say, the XY plane? Now this is kind of a cool one. Let's take a look at the XY plane. In other words, let z equal 0 now. And watch what we get. -x squared plus y plus 1 squared equals 0. We would get x squared equals y plus 1 squared. Or x equals plus or minus y plus 1. And if you notice right here, we have 2 lines. Right here. Now, you might remember, so what we have here on the xy plane, I'm going to have these 2 lines on the xy plane. And I'm just going to draw them. There's one line, nothing perfect. There's my other line, like this. And to make this a cone, I'm going to make these circular ends right here. So it's going to go like this. And we get our cone. Now notice it didn't open up on the x-axis, but more along the lines parallel to the x-axis. And there is our elliptical cone. Right, number 4. This almost looks like similar shapes, but it's something that doesn't match anything on my graph. Because the only thing that's 0, it could maybe the elliptical cone. No, the cone has to be equal to 0. It got that 9 right there. So really what we want this to be is 1. We want this to equal 1. So I'm going to do that. So this becomes 4x squared minus y squared plus z squared equals -9. And if I divide by -9, we would get y squared minus 4 over 9, 4y squared over 9. Oops, I messed up there. Let me start over. There we go. Divided by -9, we would get y squared over 9 minus 4x squared over 9 minus z squared over 9, and that's going to equal 1. And hopefully you recognize this is our hyperboloid of, let me see here, 2 sheets right there, where 2 of them are negative or 1's positive. So this is our hyperboloid of 2 sheets. So to graph the hyperboloid of 2 sheets, so looking at the odd one out is y, odd one out is y. So therefore we know that this is going to open along the y, or open along the y, or parallel along the y. So to graph this, the first thing we want to find out, since I know it opens along the y, we are going to find out where this intersects the y-axis. Well, that's pretty easy to do. We just let x and z both equal 0. Very easy to do. So this is going to become y squared over 9 equals 1, or y is plus or minus 3. So at 3, 1, 2, 3, and back 3, 1, 2, 3. And I just draw hyperbolas opening up on that axis. And then I can just draw a little bowls here, like little bowls. Gives us some 3D shape there. And sometimes I'll do this right there. And there's our hyperboloid of 2 sheets. So I just, like I said, find my y axis, draw my hyperbolas, and I just draw my three-dimensional shape. All right, the last one. Okay, let's see here. If I look here, oh look, there's no x. There's no x's, right? So hopefully remember that this is going to be a cylinder. But what type of a cylinder will this be? That's pretty easy to notice. If I divide by 36, we get y squared over 4 plus z squared over 9 equal to 1. This is our elliptical cylinder. It's an ellipse, so we call it an elliptical cylinder. Right there. And so to graph this, ready? Okay, so to graph it, we're just on, basically we are on the YZ plane. So we're going to graph an ellipse on the YZ plane. So how do we do that? Okay, I know y on the y-axis is going to be plus or minus 2, and the z's is going to be plus or minus 3. So plus or minus 2 on the y's, plus or minus 3's on the z's. Whoop, missed it. There's my ellipse right there, and I draw a cylinder. Because x is missing, we're going to stretch along the x. Like a slinky along the x. Like so. And there is our cylinder right there. Okay, there's one more I want to go over with you. Please go to my next video. We'll talk about that one. Okay, it's a very big one for us. Okay, I want to make sure that we cover the hyperbolic paraboloid. This is going to be a big one for us. Okay, so one more.